Today we are going to learn about the structure of atom. Now, you have already learned about the structure of atom at a moderate level in your high school classes, but now we are going to have a little higher level of understanding about the structure of atom. Now, I'm sure you have learned the Thomson's model of atom, which is otherwise known as the watermelon model or the plum pudding model. Sometimes it was also known as the raisin pudding model and so on. Now, that model did not have any real significance except that it was able to explain the electrical neutrality of the atom. Now, because of many reasons, for example, it wasn't in agreement with many experimental observation and therefore that was abandoned. Now, the next and one of the most successful model of atom was the Rutherford model of atom. In the Rutherford model of atom, well, the mass particles of the atom, namely the protons and neutrons, are concentrated in the center of the atom in a very small place, and the electrons are supposed to be revolving around the nucleus in definite orbits, just like the various planets revolves around the sun in a solar system. So here the nucleus has the role of the sun and the various planets takes the position, or they play the role of the electrons. The electrons play the role of the planets. Okay. Now, in that case, you know that the electrons moving around in the orbits with a definite velocity, but you know that the electrons are negatively charged and the nucleus is positively charged. So there must be naturally some electrical interaction between the positive nucleus and the negative electrons, so that there is attractive interaction between them. So the nucleus must be constantly pulling the electrons towards the nucleus. But the fact that the electrons do not fall into the nucleus is because there is an equal and opposite force acting. That is the centrifugal force of the electrons. Since they are revolving around in an orbit, there is a centrifugal force, and in this model, you know that the attractive force between the nucleus and the electrons is equal to the centrifugal force of the electrons. So they balance. This was what was supposed to be the case of the Rutherford model of atom. Okay. Now, this model was also not accepted for some reasons. Now, the most important reason raised against the Rutherford model of atom was that it was not able to explain the stability of the atom. Now, if an atom has to be stable, the electrons must continuously revolve around the nucleus without falling into the nucleus. But the electron being a charged particle, we know that according to the classical theory of classical electromagnetic theory, we know that a charged particle under acceleration is bound to lose energy in the form of electromagnetic radiation. Now, in the case of an electron, even if the electron is moving with a constant speed around the nucleus, it is continuously changing its direction, and therefore it is not moving in a straight line, and therefore it is always under acceleration. And acceleration can be caused by a change in speed or a change in direction. So since there is acceleration, the moving electron must be continuously losing electron, and therefore the electron will lose its energy continuously, so that the radius of the orbit in which it is revolving becomes smaller and smaller until finally it falls into the nucleus. That is, if, for example, if this is the nucleus of the atom, positively charged nucleus, and if this is the electron. In the beginning, the electron is revolving, describing a path or an orbit of large radius, and as it loses energy, it goes on describing orbital of smaller and smaller wavelength until finally it falls into the nucleus. And that is the end of the atom. So long as the electron is in the orbit, it is stable, but when it falls into the nucleus, the stability ceases. And therefore, this model was abandoned. This is one of the very important defects of the Rutherford model of atom. There was also another drawback for the Rutherford atom, that was it did not give any explanation for the extranuclear structure of the atom, that is how the various electrons are arranged outside the nucleus of the atom. These were the two main drawbacks of the Rutherford model, and therefore that was abandoned. The next successful model of this for the structure of atom was the Bohr model of the atom. Now, in fact, there was a time gap between the proposal of the Rutherford model of atom and also the Bohr model of atom, and in between that time gap, two important developments took place in the scientific research about the structure of atom. One was the dual character of electromagnetic radiation, and the second one was the emission and absorption spectra of hydrogen, the discovery of the emission and absorption spectra for hydrogen. Now, when we talk about the dual character of electromagnetic radiation, now electromagnetic radiation was considered to be a particle. It is the movement of a particle. That theory is known as the corpuscular theory of electromagnetic radiation, in which light rays are considered to be made up of streams of particles flowing from the source in all possible directions. That is the particle theory of electromagnetic radiation. Now, later it was also found that electrons also have a wave nature. Now, in certain properties like diffraction, interference, see, these are certain properties which cannot be explained by the particle nature of light or electromagnetic radiation, while on the other hand, you find that properties like blackbody radiation and photoelectric effect, these are properties which can be explained only by the particle nature of light and not by the electromagnetic radiation. See, for example, if this is the nucleus, let's say it is positively charged, and you have the electron a little bit far away from the nucleus, revolving around the nucleus like this, and because of the fact that it is losing energy, it describes an orbit of smaller radius. It becomes smaller and smaller and smaller, and finally it falls into the nucleus. Now, if this thing happens, the atom has no stability. So therefore, this was a very, and Bohr calculated the time the electron would take for this kind of a fall. It takes less than 10 raised to minus 8 seconds to fall from the outer orbit into the nucleus. So you see, the atom dies in no time, in a split second or a fraction of a second. There was also another important defect for the Rutherford atom model. The Rutherford atom model was, there was no provision in the Rutherford model to explain the distribution of the electron, the extra nuclear electronic structure. Nothing was mentioned about that aspect in the Rutherford atom model. So because of these two reasons, the Rutherford atom model was abandoned. Now, the next important model of atom was the one which was given by Niels Bohr, which is known as the Bohr model of atom. Bohr model of atom. Now, in fact, between the time Bohr came out with his model and the old Rutherford model, there was a time gap, and during that time gap, certain important development took place in the scientific research on the structure of atom. And one was the discovery of the dual nature of electromagnetic radiation, and the second one was the discovery of the emission spectrum and the absorption spectrum of the hydrogen atom. Now, we have to understand what is meant by the dual nature of radiation. Now, light is considered to have a particle nature, in which light is considered to be a stream of particles flowing from the source and traveling in all possible directions. That is what is known as the particle nature of light, and that is known as the corpuscular theory of light. Now, there is another nature, or there is another behavior of electromagnetic radiation, that is, it is associated with a wave-like motion also. As light travels from the source to any direction, it moves like a wave. Now, that is known as the wave-like character. Now, certain properties like diffraction, interference, etc. cannot be explained by the particle theory of light, but they can be explained only by the wave theory of light. On the other hand, certain other properties like blackbody radiation or the the photoelectric effect, etc. can be explained only by the particle theory of light and not by the wave theory of light.